Alrighty guys, today's lesson is the third lesson in Unit 5, and we're going to be looking in our reference tables, pages 8 and 9 today. But let's just do a brief, short lesson on fossils in the rock record. Now, as you know, rocks talk to all of us, our science teachers, and here's what they have told us. First, Earth was once home to lots of different kinds of life, huge variety, all kinds of interesting creatures, sometimes kind of crazy looking. Most of that life, probably 99% or so, is now extinct. There wouldn't be enough room on the Earth if everything that was, all the species that have evolved are still around now. And this evolutionary process is normal. Now, we do know that we have a higher than normal extinction rate for a species today because of man and our impact on the planet. But over Earth's long history, this evolutionary process is normal. You need it. So extinction happens. And here's some extinction, or a type of life form that has gone extinct, the Ediacaria fauna. Ancient sea life, multicellular. So in a few moments we're going to be looking at the geologic time scale in our reference tables. Geologists, it's the way of geologists representing Earth's history using the fossil record. So when we look at this scale in your reference tables, it was mainly built, not all, but mainly built on the evidence from fossil life. And unlike time, the geologic time scale has no fixed units. There's no seconds, minutes, hours, days. It's based on the first appearances and extinction events of fossils, basically the start and stop buttons for each period. And so with that in mind, this is a double spread layout of pages 8 and 9 of your reference tables. I'm going to stop the PowerPoint in a moment and show you a better version of this that you can actually read. But just to give you the general overview, on the far left-hand side, we have the eons. Okay? And there are, on your reference tables, the Archean, the Proterozoic, and the Phanerozoic eon. So there's 3 eons. The 2 eons below this thick black line right here are in the Precambrian time. That means before the Cambrian period. And the Cambrian period, essentially, if you follow this thick black line around here, starts right there. Now, all that gets jammed up into this tiny spot up here. There's just not enough room to write all the detail down there, so they had to zoom this part in, and that gets confusing. Okay, moving over, you'll see that these periods, they line up. In your reference tables, pages 8 and 9, everything lines up. So everything in the Silurian period right there, Devonian period right there, all the way up to today, the Quaternary period, all this stuff right there. And you'll see these various pictures of the Earth and the continents and where they were. They have arrows pointing to the time periods they represent. And down below, we have New York State fossils with letters. And they are represented in your reference tables in this area with the letters showing bar graphs representing the time that they existed. The actual letter is the period in time when those fossils were found. Okay, with that in mind, let's stop this show. Let's go right to the reference tables. And here's a much better view of page 8 in your reference tables. And some things you should be aware of. The estimated time of the origin of the Earth in the solar system, 4,600 million years ago, which is 4.6 billion years ago. And these lines separating the Archean eon here, you can estimate around 2.5 billion years ago. And moving up, the end of the Proterozoic eon, it's around 500 or so million years ago, but you can get the exact number if you just follow that zoomed in section down here and you get 542 million years ago. Now it does say million years ago up here. Moving up through the periods of the Phanerozoic eon, we have the Cambrian, the Ordovician, the Silurian, the Devonian, the Carboniferous, and the Permian. The Permian ends when the Paleozoic era ends because of a mass extinction of many land and marine organisms, including trilobites. Then we start a new era, the Mesozoic. We have the Triassic, the Jurassic period, the Cretaceous period. This is our dinosaur age, which ends, the Cretaceous period and the Mesozoic era end at the same time with, 65.5 million years ago, the mass extinction of dinosaurs, ammonids, and many land plants. That was the meteorite impact down off the coast of Mexico and the Yucatan Peninsula. And that starts the Cenozoic era, which is the era of mammals. We have the Paleogene, Neogene, and the Quaternary period, which we're in right now. All part of the Cenozoic era. And I hope we don't have any extinction events anytime soon, because if that happened, the Quaternary period would have to end. But this is when the humans have existed. And these are all in millions of years. So you get up here when it's decimals, and 0.01 means about 10,000 years ago, the end of the Pleistocene epoch. And you can see there's lots of these going down, but most of the old ones are just early, middle, and late, or late and early. And they have much more detail about the epochs up here because the fossil record is relatively recent and much better fossils exist. Okay, the New York rock record shows record in the rocks. If you have a bar right here, it means we actually have rock record in New York State during these time periods. Here, there's evidence of those things in New York State, but you see there's actually time periods here and down here when there's no record at all of these things. The Permian period, for instance. No record at all of anything in the Permian period in New York State. So you got to go elsewhere, other states, other countries, to find evidence of that time period. Okay, let's quick scan over to the next page in your reference tables. Hopefully I can erase all this real quick. Nope, it's not going to be nice to me today. Okay, now page 9 of the reference tables, you can see these bars here, the time distribution of fossils, including important fossils of New York. The center of each lettered circle indicates the approximate time of the existence of a species index fossil. And so if we look down below, we can see, for instance, let's pick letter Z, the end of the alphabet, the Mucrospirifer. Okay, you find that on the chart. The Mucrospirifer is right here, letter Z. It's a brachiopod, that's the type of organism. And letter Z existed, if you go all the way over that side, and I'm not going to pull this reference table page down, but you can find out what period that was in Earth's history and about how many millions of years ago the thing existed. You could also know that it coexisted with all these other organisms, or very similar time to all these other organisms, because they almost line up together. And looking at these different time distribution bars, you'll see that there's the trilobites, which are non-existent anymore. They're extinct. We have the nautiloids, which are still around because the line's right up here to today. We have the ammonoids still around. Or no, actually, they became extinct. Sorry, right there. The crinoids, which are still around. The dinosaurs became extinct there at the end of the Cretaceous. Mammals, still around. And we formed a little bit after the dinosaurs. Vascular plants, still around, obviously. Trees, for instance. Birds, still around. Actually a form of dinosaur. And corals, still around. Gastropods, brachiopods. The placoderm fish didn't last too long. Not the most successful things on Earth. Okay, and moving on to the last couple things here. You'll see the important geologic events in New York State. Important geologic events. Things that we learned about in Unit 3, for instance. For example, the Acadian orogeny caused by the collision of North America and Avalon, closing the remaining part of the Iapetus Ocean. The Alleghanian orogeny. Anytime you hear the word orogeny, it means mountain building event. Caused the collision of North America and Africa, forming Pangaea. So in between these two time periods, Pangaea forms. Pangaea begins to break up not too far after that. And you can see in the picture there, the first Atlantic Ocean starts to form. And so you can look here for all different kinds of things that have happened as far as geology goes in New York State. The advance and retreat of last continental ice, some more orogenies down here. And then the last part, as I already mentioned, shows North America shaded in black and our position relative to other continents and the Earth over time. So that's about it for today's lesson.